Hello, I'm jaeseopkong, who is going to represent about
Hello,
RFIC
I am
Midterm
Pong
exam.
Jae-seop who is going to represent about RFIC Midterm exam.
So the
So this
table
is
of
the table
contents
of the
are like this. I'm
contents.
going to
I'm
explain
going
about
to
MMIC,
explain you about
GAAS MOSFET,
MMIC,
INGAP
GAAS MOSFET,
HBT, low noise
INGAP,
amplifier, Smith
HBT,
chart,
and
amplifier
NMA,
and
Smith
mixer, and for the
chart,
last
amplifier,
BJT.
mix. So
So
MMIC
the MMIC, which is
the
called
flower of
the flower
RF
of
active
RF active
circuits, refers
circuits,
to a
refer to
circuit
a circuit that brings various
passive
passive
devices and
devices and parts along with
along with
semiconductor
semiconductor
devices
devices
on
on
one
one
semiconductor
semiconductor
substrate
substrate
at
at
once.
once.
So
Here,
this is a really
the
good
the part
advantage.
is an active
Here the
element
part is an active
or a passive
element or a
element,
passive
and the
element,
active
and the
MMIC is made of an active
active
element, and the
MMIC is
passive
made of an
MMIC
active
is made of
element, and the passive
passive
MMIC
elements.
is made of a passive
So an
element.
active element
An
is a
active
small
element is a small
instanton that can act
instanton
as an
that can act as
amplification or
amplification
oscillation by
or
receiving
oscillation
energy from the
by
outside.
receiving energy
So the
from the
example
outside.
of
It
active
is the
elements is a
examples are
diode,
the diode,
transistor, and
transistor,
OPM.
or OPM.
A passive
And the
element is
active
to
element
operate
is to operate alone
external
without
power
external power
source. An
source. And
example
an
is
example is
resistance.
resistance. So MMIC has
MMIC
a
has a
disadvantage of being
advantage of being
difficult to
difficult
design
to
and having
design
a
and
very
having a
long
very
production
long
period.
production period.
But
But
it
it
is
is
possible to
possible to
produce
produce
stably, and it is
stably, and
widely
it's
used in the mobile
widely used
devices
in
due to
mobile
its low
devices
power,
due
small
to its
size,
low
and
power,
lightweight.
small size.
And this is the structure of GAAS MOSFET.
So a while
GAAS
ago I
MOSFET
explained about the advantage and
has a
disadvantage
simple
and the
structure,
purpose of using
making
it.
the manufacturing process easy. Sorry, having a very long production period, but it is possible to produce stably, and it is widely used in mobile devices due to its low power, small size, and lightweight. And INGAP HBT. HBT is a heterojunction bipolar transistor, and the operation principle is as follows. First, the flow of holes from the base to the emitter is prevented by the high barrier of the electromagnetic band, so the emitter efficiency is high. And second, it is possible to lower the base resistance without lowering the emitter efficiency. This reduces the voltage drop between the emitter and the base of reduces the current concentration of the emitter. And for the third, because the base resistance is small, the frequency response improves. In addition, a transistor of a double heterojunction with an emitter and collector of a wide gap may be configured, and current gains in an active mode and the dynamic mode may be improved by symmetrically performing the emitter junction and collector junction. Figure shows the energy level of the NPN heterojunction transistor operating in an active mode. This is LPA, and I'm showing the picture of antenna because it is an amplifier that is embedded in an antenna to amplify a weak signal. As a type of amplification circuit, amplification circuit, it serves to amplify the weak signal captured by the antenna in the communication system and is located close to the antenna to reduce attenuation on the transmission line. It is mainly used in microwave systems such as GPS. The amplifier may be largely divided into a low noise amplifier of the receiving the input unit and a power amplification of the transmitting and output unit. An important property in RNA is NF. The NF is small. There is a less noise generated by the amplifier, and a very small level of signal can be amplified without being buried in the noise. In addition, since the level of the input signal may be small, the antenna may be small, can be also small. So, and for the next, this is the picture of the Smith chart. Smith's chart was designed in 1939 by Philip Smith for convenient calculation of transmission lines and is a circular diagram visualizing complex impedance. Currently, it is a graphic format and tool used by the numerous RF engineers worldwide. Recently, with the development of RF tools, hand calculation using the Smith chart are gradually decreasing, but the outputting various results on the Smith chart, it is still widely used in the industry, as it is possible to grasp the behavioral characteristics of transmission lines. So this is the picture of amplifier. Amplifier is a circuit that amplifies a signal, setting a bias condition so that each FET or BJT has a desired characteristic, and then outputs of the power coming in by the bias in proportion to the change in the input signal. In other words, the input signal itself is not inflated, but the bias power is sensitive to changes in voltage current of the input signal, resulting in enlarged copy results. Mixer is a and this is a picture of mixer. Mixer is a circuit that extracts an intermodulated signal of two frequencies using nonlinearity of the FET. That is, when the two frequencies F1 and F2 are mixed, harmonic components such as F1 plus F2 and F1 multiplied by F2 are generated, where the difference between the two frequencies is mainly output. And for the last, this is the BJT, and the picture is the example of NPN BJT that's working. It can be considered that there are two PN diodes attached. In the case of NPN BJT, emitter is an electron emitter, base is a roll regulator, and collector is an electron collection source. At this time, if you apply a positive voltage to the base, you can pull electron from the emitter. And if you apply a much larger positive voltage on collector, all the electrons left in the emitter will be sucked into the collector. So electron will move emitter to collector, so the current will move to the collector to emitter. So that's it for my presentation. Thank you for listening.